Welcome to a world where technology meets construction, where innovation transforms the way we handle projects. Today, we delve into a concept that promises to revolutionize the construction industry: smart bills of quantities codification. In the world of construction, precision is paramount. From towering skyscrapers to intricate infrastructure, every project begins with a blueprint. But what if we told you that there is a smarter, more efficient way to decode those blueprints, to transform stacks of unstructured documents into structured, actionable data? Join us on this journey as we explore the groundbreaking concept of smart BoQ codification, where artificial intelligence and large language models take center stage to automate the extraction of vital project information, saving time, reducing errors, and enhancing decision making. We're going to discuss today in this video the main concept behind the idea itself, what data was available at the time of creation of that idea, how we prepared it, and then we're going to dig deeper into explaining the model itself and how we implemented it. The main concept is we go on the Hugging Face website and then we download through our own IDE like VS Code or Jupyter Notebook, whatever you would prefer, the Mistral 7 billion parameter model, the base one, which is developed by Mistral AI. And then we can use the library of bills of quantities that are codified in accordance with a standard method of measurement to fine-tune that base Mistral 7 billion parameter model to produce a fine-tuned model. And then the main ask from the wider business is saving lots of time, lots of hours, and lots of days, if not weeks, of codifying new BoQs that we receive from a wide variety of parties in the construction industry. So these uncodified new BoQs can be fed into the fine-tuned model to finally produce a codified BoQ or bill of quantity to be used further and do some sort of benchmarking and predictive cost analytics and the likes. So the data that was available within the scope of this exercise were codified BoQs, which I have done previously. So let's take one activity for example. I've deleted all of them other columns, included the unit of quantity, the rate, the total. They were outside the scope of this exercise. So let's take this activity for example, trapezoidal curve to cycle path. I've codified it using NRM1 and up to level 3, and as you can see here, these are the correct coding, or this is the correct coding used for that specific activity, which I'm going to be using further when I'm undertaking the prompting and building the back end for the conversation between the user and the AI assistant. So the data manipulation started with understanding each and every single activity and how to build a conversation between myself as an end user and the AI assistant. So I had multiple thoughts. The first one is go to the Hugging Face website and then go to one of the largest data sets that is used to train large language models such as Llama, such as Mistral and the likes. That data set is, I think the size of it is about 10 gigabytes and it contains about 775,000 rows of data. In each and every single row, it's basically a dictionary composed of ID and the data is a list of strings, which are basically questions and answers, or as they call it, question and answer pair. As you can see here, there is a question being asked, and then there is a lengthy answer afterwards. So I thought about doing the same thing. So as you can see here, I asked different questions. So, did you hear about, or do you have information about this specific activity? Yes, I have. So give me the first level of coding, and that's it. Is there any more? Yes, there is. Is there any more? Yes, there is, until there isn't. And that's based on understanding the data that I have myself. I have here, for argument's sake, I just have 3 levels in the NRM1. I know for a fact that section 9, for argument's sake, it is composed of 4 levels in NRM1. Which is basically section 9 is preliminaries. So I know for a fact that there is nothing here that is going to be given if there is a question asked about NRM1 level 4. I've tried that concept. Unfortunately, it didn't work out because the training has to be done on a question and answer pair. So the second way I used is, first of all, you have to transform that data or save it into a CSV file, which is going to be imported into the large language model for fine tuning. So that's what I have done. So basically convert that sheet into a CSV file. I have manipulated this CSV file a little bit by adding ID, and then the question is the main question in the Excel sheet, and then the answer is everything. So I've basically compiled all of them answers in one line. So that is basically the main data set that I've used. I've heard a lot of people speaking about transforming that to JSON, building that into a dictionary, but that wasn't quite relevant to my case. So jumping to part 4, the walkthrough through the actual code. So let's take a step in understanding the environment which I'm using for the development of that code or that solution. So I'm using the development version for Python is 3.11.5. I'm using, as you can see on the screen, Visual Studio Code as the IDE developer. And then there are a number of Python packages that have to be installed before you could crack on with this code, including TRL for the fine tuning, PIFT, which is parameter efficient fine tuning, that's quite important for the fine tuning of large language models, pandas for dealing with data frames, arrays, matrices, vectors, and the likes. Datasets, that is quite related to the datasets downloaded from the Hugging Face website, as well as conversion of other datasets to the format of the Hugging Face website. You have to download PyTorch, and if you're using a graphics memory, which you would have to do, you would have to download Torch with CUDA, because training or fine-tuning of large language models is much faster on GPUs. It can be done on CPUs, but that is going to be quite slow. TensorFlow, it's the same like PyTorch. It has its own uses. It might be used in this code, might not be. Transformers, that is the underlying package or module for anything related to natural language processing nowadays. Bits and bytes, that is quite important for the quantization or the compression of the large language models, the configuration of it, as well as identification of the weights and biases for the imported large language model. If you're going to be undertaking training and fine-tuning of large language models on a consumer PC, it has to be top-end. Mine, it's a top-end PC. I purchased it a number of years ago, so it has the old Core i9 12900 with 24 cores. I have RTX 3090 for the GPU, and I have a 4800 megahertz RAM with 32 gigabytes in memory, and it's a DDR5 RAM. Importing the libraries comes as the first step. So the Ruby of the code itself is to import a specific data set and then convert the dataset to be in the form or in a format that is understood by the large language model, which I'm going to explain in just a little while. So first of all, I have had the CSV file, which I've showed you previously, and then my delimiter is the semicolon because my computer is in French. And then what I'm doing here is that I'm importing the data to be in a data frame composed of just 2 columns, ID and data. The column, which is called data, is a list of lists, and that's the thing. You have to have a list of lists. I've seen a lot of people speaking about having a JSON file and the whatnots and dictionaries, and in my case, it didn't work out. It just worked out to be a list of lists. And that code here, which is basically converting the training data set into a format that is understood by the large language model, which is, I think it's called Arrow dataset. So as you could see here, it's a list of lists. I'm showcasing the data, so which is basically is composed of questions and answers. So question and the corresponding answer. Question and the corresponding answer, so on and so forth. These two are called questions and answers pairs. jumping to the loading of the large language model itself, that's pretty straightforward. You just what I've done here is that I have stated what model I want to import, which was the base Mistral 7B model developed by Mistral AI without any sort of fine-tuning or tweaking done by the bloke or the other lads on the Hugging Face website. And then I have imported, or basically I'm doing the quantization configs using the bits and bytes library. There is a little bit of a problem with the bits and bytes library that I've noticed on the Hugging Face and GitHub community websites, and one of the members, he did the solution that I'm highlighting here, and everything went well because I had a problem with bits and bytes library. What I'm doing here is that I'm loading in 4-bit to allow for maximum quantization. Definitely there's going to be a loss of quality, but 4 bits is fine. Here I'm using the floating point 16 for the computation itself, which gives some sort of like a balance between the loss of quality but memory efficiency. And here is non-linear. That is a non-linear quantization method to optimize the presentation of the numerical values within the model. And then what I'm doing here is that I am downloading the model, which I've stated above here, as you can see here, and I am importing the quantization config or the compression configuration for the model, and importing as well the tokenizer, which breaks down the text into tokens and then putting them in a vector, which I am doing the padding for here, so that all of the vectors have the same exact number of entries. Moving on to the LoRa, which is low rank adaptation, which is all about the parameter efficient fine-tuning of the model using training of a specific number of parameters of that model. So I'm specifying here the configuration for the low rank adaptation by specifying the attention blocks to apply to the LoRa update matrices, and also what is the rank that is going to be used. I've read a lot of articles from DeepMind, and they say that anywhere between 4 and 16, that's the sweet spot. Here I'm saying that I'm not going to be training any of the bias parameters. You're free, you can do whatever you please, and I'm adding the LoRa layers to the model. In this step here, I am initiating the training arguments for the chosen large language model, which is basically Mistral 7B in my case, version 0.2. I'm beginning by specifying what is my Hugging Face website, Hugging Face username. That is not relevant in this sense. I've just put it, for formality purposes, but that is not important in this exercise because I'm not going to be pushing the trained model to Hugging Face hop. I'm just going to be using it offline. I'm inputting what is the output directory, so the output directory is going to be on my machine. How much or how many batches that are going to be dealt with by the GPU, and also the gradients that are going to be dealt with the GPU. And here I'm specifying the optimizer, which is Adam W optimizer with 32-bit precision, which is has a very high precision here. What is the frequency of saving checkpoints? Here I'm identifying 10. And then how often the training logs are going to be trained. The learning rate that was already advised by the Hugging Face website, it's pretty standard to be using 2 multiplied 10 to the power of -4. And here I'm specifying what is the maximum value for the gradient norms, so that we can evade the explosion of gradients. I think the most important parameter here is going to be the maximum number of steps, because that is basically the maximum number of steps for the training or the fine-tuning of your model. All of the projects that I've seen for the Hugging Face website, they have 1,000 training steps, but that is to commercialize a model. But for my case, it's just basically going to be 50 steps, which took me about 15 minutes in training. But if you want to commercialize a solution, I think you might need quite close to 1,000 steps, which is going to take about half a day. Here is the warm-up ratio, which is basically identifying how many of these steps are going to be like a warm-up for the model during training. I'm identifying 3%. And here the learning rate is constant throughout the whole learning process. And here it's basically I am putting all of them values here into the training arguments function. And here, as you could see, I'm just saying that I'm not going to be pushing the model to hop because I'm not really interested in working online. I'm just interested in this instant and working offline. Moving on to the model training. So the model training, what I'm doing is I'm using supervised model trainer, which is you can download it from the TRL package. And what I'm doing here in this step, I'm giving the large language model an example to train on. So I'm saying that you have to use the data and you have to use the first entry in the data in whatever data set that you're going to have. So it's specifying the data column and the first entry in the data column, which is as you could see above, it's the question. So I'm telling the model, use that as the question to train and use that as the answer to train. That's what I'm doing here in that step. So the first entry as the question, and the assistant is going to be responding by the second entry, which is the answer. And here I'm specifying the training arguments for that trainer. We have specified the training arguments above, the model already downloaded, training data set that has been already imported above. The packing is related to the data processing and the patching. What column is quite important for us is the data column. I'm here also specifying the tokenizer, and that is the maximum sequence, which is the maximum length of data. So anything that is above 124 tokens, that's going to be split. And then here I'm applying the formatting function, which I have already declared here. The last step in the training really is basically training, trainer.train. That's it. Here is a mini step, which is saving the trained model. So I'm specifying which folder on my PC to save the trained model on. And basically I'm saying trainer.save model in the required or the chosen directory. Now it's time to test what we have built. So I'm importing some important packages, torch and transformers, and basically I'm specifying again where I've saved the model so that I could import the model in both the tokenizer and the model itself. I'm specifying the quantization configuration. So basically these lines of code are the same as above, nothing new here. I've repeated them because testing the model can be done in a separate file. So in a separate file you would have to specify all of the bits and pieces again. And here is the interesting part. So I'm trying to test the model by giving a prompt. What is the NRM1 coding for testing and commissioning? And I'm awaiting the assistant to provide me with an answer. And here I'm just identifying some traits or characteristics for the inputs and the outputs. So here I'm just saying that whatever inputs I'm going to give you, tokenize them and then put them in the first GPU. And I'm always having one GPU, so it's going to always be the first GPU, which is that one. And the tokenization is going to be, the output is going to be in PyTorch tensors. Here the outputs, it's going to be taking the tokens from the inputs, and then the response or the generated text should not exceed 250 tokens. And here I'm using the deterministic way of generation of outputs. And here is basically I am printing the output, including the padding and the likes. And let's discover ourselves. Let's read together what had happened. So using the LoRa method that we have discussed before, what is the NRM1 coding for testing and commissioning? Okay, so the answer, I have already put a specific template for the answer. So in order to understand NRM1 coding for an activity, blah blah blah, we have to understand first the hierarchy of the codification of this activity with the NRM1 method of measurement. Okay, that is standard, fine, nothing fancy here. The first level of hierarchy of this activity is lying within section 9. that is quite interesting because that is 100% true. And then it doesn't only say that, but it says that as for level 2, and that is exactly the same wording that I wanted it to have, as for level 2, the activity testing and commissioning lies within or on the subsection 9.2. Wow, that is really fantastic. 9.2 main contractors cost items. That is pretty decent. And then it doesn't only stop here, but it says that I also have access to level 3, which is exactly what I told it to do. That if you have access to level 3, do not spare the information, spit it out. So it says that in section testing and commissioning is existing in subsection 9.2.11, and that is true. I'm really amazed by the performance. That is absolutely amazing. And then it says, last but not the least, I'm afraid that in this case I do not have any access to further level of details. From my knowledge, the level coding information is only existing in section 9 preliminaries. That is true, but I think, I'm not entirely sure, I haven't memorized up to level 4, but I think there might be a level 4, but at least if you could codify a BoQ up to level 3, that is 100% fantastic. You can use it for benchmarking and the likes, as well as cost prediction. And then I'm comparing and contrasting here in the last step. Basically, that step is exactly like the same. It's exactly like that one here. It's the same. But what I'm doing is basically removing the LoRa. So basically using the model itself, the base model, without any sort of fine tuning and the likes. The answer is quite shocking to say the least. What is the NRM1 coding for testing and commissioning? It says that, yeah, I'm here to help answer questions, but it seems there might be a misunderstanding in your query. The term NRM1 is not directly related to testing and commissioning, which is 100% false in the context of electrical or electronic systems. Instead, it's a term used in the National Regulatory Reform Act 1996, specifically in the context of Occupational Safety and Health Administration and the Environmental Protection Agency. That's a bit of a faff, really, and for me it doesn't serve the purpose. But this means that the LoRa model is absolutely spot on, and it allowed us to have up to level 3 of details in codifying a specific activity. That's all for today's video. If you want to have further insights about the application of AI in the construction industry, or if you are curious about how to get a chart from the RACS, we can provide you with support on both flanks. Visit us on www.apcmasterypath.co.uk and enhance your career.